Well, I guess we can go ahead and start. Oh, one more person. Okay, the B series is not as big a draw. Next week we will start the C series. We'll be talking about conference presentations next week. And so I think for all of you, if you have especially academic careers in mind, you should definitely attend that. We'll be talking about how to get started with conference presentations, which is how you get started with developing your reputation and your research in an academic field, because conference presentations can lead to then later, well, networking, but more importantly, publications. And we'll talk about getting started with hitting the conference circuit, how to do conference presentations well, and how to make that form the foundation of a later career in publishing. As well as teaching, and include vocal delivery techniques and practical techniques of finding conferences. Okay, so today we're talking about interactive classroom activities, which I think is fun. When I started teaching many years ago, my teaching was fairly traditional because that's mostly what I had known as a student, especially as a language learner, taking different language classes in college. And so when I became a language teacher, I did the same. But over the years, I've grown more into an interactive teacher. And it took me a while, because when I studied in a master's program in teaching English back in the States, we took courses, one in particular, where we were told how great group activities are for language classes. Then I tried it. I came over here 12 years ago, tried teaching freshman English, and it failed because the freshmen were unruly. They didn't want to pay attention. I put them into groups to do group work, and do they do what they're supposed to do? No, of course not. They chat, they talk in Korean, and they don't try to use English, and they don't really do what they're supposed to do. And so I was disillusioned for a while with group activities. Then later, when I was doing my PhD, I got exposed to group activities done right. When I was in the Matt Tessel program, we were taught in a very theoretical way. This is how great group activities are for language learning, but we were never taught anything practical. When I did my PhD in educational psychology, I got more of the psychological background that you need to understand to know how groups work and how to do group activities. And then I served as a teaching assistant under a professor in education who was a master at doing interactive classes. He was a master, and he had one of the most popular classes. He could turn a class of 300 kids into an interactive experience, and he was also a bit of an entertainer too. So I learned from him, and then I came back here and I started over time teaching more and more interactively. And I found that my students respond to it. They appreciate the change because my students are tired of traditional teachers, and so they tend to like my classes when I do classes that are more interactive. And so we'll talk about interactive classes and general classroom dynamics. So first of all, there's some questions here. Number one, I'll let you discuss maybe with a partner. Get into pairs and discuss these questions under part one. What do you do when your class is too big? Students don't respond to your questions. You ask questions and they don't seem to work. You try to get students to ask questions and they don't. So what do you do in this kind of situation? So talk to your partner for a moment and discuss these questions. Okay. First of all, okay, your class is too big. Right now I'm teaching a composition class. It's an advanced composition class. It should have 25 students at most. I've got 35, way too many. Or you're a professor. What happens when you're a professor? Undergrad courses might be 80 students, 100, 200 students if you're a professor teaching required undergrad courses. What do you do with a big class? You could just talk for a whole hour and put them to sleep. We talked about that already. Not the best option. What else can you do with a big class? Ideas? Yes.
TA session.
TA session, okay. So in Korea, do you have kind of like discussion sections for big classes? Because in America, so for example, this education professor I mentioned, a lot of undergrad classes are like this. There's a big lecture hall with maybe hundreds of students. So there's a main lecture by the professor for maybe one session a week, maybe 1 hour a week. Then they meet in discussion sections that's led by a teaching assistant. This is in the American system. About maybe 20 or 30 students in a class, and so it's kind of a supplementary class with a teaching assistant, maybe just some extra stuff that builds on the professor's lecture. And I guess you don't have that in the Korean system. It's kind of a nice thing because it also gives grad students jobs and teaching experience. Okay, what else can you do with a big class? Okay. Get to know all 200 students?
Like actually, like not all, but even knowing a few of them and kind of addressing the individual students during lectures is kind of effective because students rather get surprised with the teacher when they don't expect it. The teacher knows their name.
Yes.
Kind of, like just like very sit straight kind of short comments. I think that is like at the least.
Yes. And I'm not good at names. I have to use memory tricks to remember names, but that can be helpful. Memory tricks, like for example, if I meet a name named Barkley, I associate his face with broccoli. I imagine he looks like broccoli, or I imagine broccoli growing out of his head, broccoli, Barkley. And with Korean names, of course, you can make some kind of a cute mental image based on the meaning or possible meaning of their Korean name. A possible interpretation of their Korean name, if you know Korean. Okay, what else can you do? Can you do group and interactive activities in a big class? Yeah, yes you can, and I'll show you an example later on. So you can do group activities in a big class, especially with undergrads. Crowd control sometimes becomes a problem. The managing the students. That's one problem I had, is managing the students. How do you manage the students? How do you get them to stay on task? How do you get them to do what they're supposed to do and not start just chatting, gossiping about their latest K-pop band or their latest celebrity or whatever?
Sometimes it's really difficult. Depending on the class, once they are being grouped, you could give them tasks, and then you would also supervise to make sure there's participation and award marks for participation. Yeah,
I actually award points for participation. Participation in my classes are usually 10–15% of the grade. You or your teaching assistant, if you're prof and you have a TA, they can help you with that. I also, of course, walk around when my kids are doing group works. Maybe you designate somebody as a team leader, and a team leader is supposed to make sure they stay on task. And also if they know that I'm going to maybe call on them, that helps. If I'm going to call on some groups to give an answer and they know they're going to have to possibly give an answer, giving points, giving rewards or something. I hesitate to give rewards if you're teaching kids, maybe, but rewards are only good for the behavioral part. You don't want to give rewards for performance, for achievement, but if it's purely behavioral, like, you know, they're paying attention or they're staying on task and such, little rewards, I don't know, like stars or chocolates might be okay for that, but not for actual achievement. Giving awards for achievement, like doing well, that undermines their intrinsic motivation, as we've talked about. Sometimes it's the kind of questions or tasks that you give them. And this is one problem I had. I was taught in a very theoretical way at first in my master's program. We weren't really taught how to effectively design materials, curricula, questions. And so, what are effective questions? And so sometimes my tasks early on failed because it wasn't a very well thought out task. I tried to give them tasks, something to talk about, but I didn't really connect it with real purpose. I fell into this rut where I was just frustrated. I didn't know what to do, so I just want to get them to talk. So I just have them do some random task, and I didn't really have a clear objective. I mean, why am I doing this? Is it going to connect with maybe an actual lesson on some, so if I'm having them do some kind of task, is this task really about a particular grammatical form, or a particular communication skill, a particular aspect of pronunciation? Is it grounded in something? And so they failed because I didn't know what to do. I was overwhelmed by the situation of teaching 5 classes a week of 30 kids who didn't want to be there. And so my tasks weren't very well grounded in a particular lesson objective. So in retrospect, I should have maybe thought about a better syllabus with specific objectives every day, like maybe particular communication strategies or pronunciation strategies, and then a group activity that goes along with that. So one problem was poorly designed tasks that lacked an objective, and before or after the task and objective, I can communicate to the students, we're going to do this activity, and before or after you explain to them, or they can see that it had a clear purpose and that they learned something. Mine were just kind of too open-ended. So that was one problem that I had. And that goes along with the problem of asking good questions. So asking good questions, questions that are interesting and stimulating, worth talking about. Sometimes professors throw out questions that are boring, right? They don't really make you think. So you have to think from the student's perspective. Is that an interesting question? Is that going to make you think? Is it something you'd want to talk about in a group or such? Other things we might have mentioned before, with Korean students especially, there's this shyness in classroom discussion, whether it's asking questions or answering questions. And so we kind of talked about this before. They're afraid of looking dumb just by asking a question, or they're afraid of looking dumb by having to speak in English, and if they're not confident with their English. Even when professors say, okay, ask it in Korean and I'll translate it, they're still shy because they'll still look, they think, maybe dumb, or they're afraid of this hierarchy. There's traditional hierarchy that's still ingrained into their psychology between the professor and the student shouldn't say anything. So what do you do there? You want them to talk? Well, like I said before, like what you're doing, instead of just throwing out questions and maybe calling on students or expecting a student to answer, and instead I'm looking at a bunch of blank faces. This is what a lot of professors tell me they experience. Instead I'll do like what I just did. I will have you discuss something in pairs. And in fact, if you and your students are not used to doing group work or interactive classes, this is a good way to start. I always tell professors, if you or your students are not used to group activities or interactive classes, start small and practice and get used to it. Start with simple discussion questions that you can give and say, hey, discuss this in pairs with a neighbor for 1 minute or 2 minutes. And then call on some of the pairs and get them to go. You know, sometimes you can even get differing responses, and I'm okay, do you agree with that? Or why or why not? Do you agree with what she said? And you know, sometimes you can get something going. Then you can work up to slightly more complicated questions or tasks that might involve small groups after that. And after a while, you can even make this a regular part of your syllabus and your lessons, and even part of your grading system, like a 10% of their grade is based on participation. And so there's some stuff here on some ideas for better questions. So poor questions are questions that have a simple answer, or just require students to just repeat back something they could have memorized from lecture or textbook. Better questions might be questions that are a little more open-ended, that require them to think, or questions that ask them to apply something. And we've talked about this. How would you apply it to a new situation? Or here's a case study, here's an example. How would you apply the principles we learned last time to this case study? You give them a case study or an example and have them apply what they should have learned to analyzing a case study or case example. There are various other kinds of questions that might be applicable to your field, but ideally questions that are maybe more open-ended. Questions that get them to analyze things, or where they have to synthesize things, where they have to draw from different things and come up with creative answers, creative solutions. And evaluative or critiquing questions. Is this a, you give them something to think about. Is this a good idea? Is this a good theory? Compare these two models and tell me which is better. Some kind of critiquing or evaluation things, especially for more complicated group activities. These are some ideas for questions and tasks. Let me talk a little bit about group dynamics, though. This is not on your handout. And group dynamics is something that I was not taught early on as a teacher. Let's think about a group discussion activity. What would be an ideal number of students for one group discussion activity? How many students per group? 3 or 4 for a lot of kinds of things. A pair, 3 or 4. 3 is what we call a triad, or so a group of 4 maybe, for a lot of kinds of class activities. If it's something more complicated, like a group project that they're going to be discussing more than one session or outside of class, you could, if it's a major project or something, then a bigger group might be okay, where they can actually divide up the labor and such things. One thing you have to think about is the physical space and tables. Are these really good tables for? No. This is not the worst, though. In old classrooms, like what I've seen in old buildings in America, I've taught in some really old buildings on my college campus back in Illinois, where you had like these individual desks. It's like a chair and a table, and it's bolted to the floor. You can't move it. Those are the worst things. Ideally, tables are individual desks or chairs that you can move around. Here you kind of have to awkwardly turn around. It's a little uncomfortable. Or auditorium-style seats, those are terrible also. You can encourage students to get up and go to a corner or aisle or something, but that's something you have to work with. If you have group leaders, or if you want to have group leaders, sometimes group leaders naturally arise. Sometimes it's okay, necessary, depending on the kind of task that you're giving them. But maybe you want to have group leaders to make sure that they are staying on task, they're doing what they're supposed to do, and maybe even go through and appoint group leaders. For a group, usually a circle or semicircle is probably the ideal thing. If you can move your chairs into a circle or a semicircle, and you have a group leader who's kind of in the center, especially if you are using group leaders. Now let's say we have a group here, and I don't want to pick on somebody, but just as an example, let's say she's the leader here, and let's say this guy's like Mr. Cool, he doesn't pay attention, and I want him to pay attention, or maybe he's really, really shy and he doesn't want to pay attention. What's the optimal arrangement here if she's a group leader, and if we have like something like a circle or semicircle? Where should I put him?
Next to me.
Either next to you or across from you. Those are, so sometimes if you have students who are not paying attention, it could be they have an attitude problem, or they're too shy, or they lack confidence or such. You could put them next to or across from the leader so that the leader can give attention to him or her. It's kind of like this. If I stand in front of you, how do you feel? Nervous. But if it's sitting down, it's a bit more relaxed. But if I'm sitting across from you, if I'm the leader, I can pay attention to you. I can make sure you behave properly if you sometimes misbehave, or if you need more help or attention, or if you're shy. If I'm sitting across from you as a group leader, I can ask you questions, or if you're across from me or next to me, I can give you extra help, give you extra explanation. So a group leader or a student who's stronger or more outgoing can be placed next to a weaker student sometimes in groups. Especially for if you're teaching kids, or if you're teaching maybe young undergraduates. What would be better? Students who, let's say in any class you're going to have stronger students, you're going to have kind of average students and then weaker students. What's best, to have a mix of students in one group, a mix of strong, average, weak students? Or would you prefer to put weak students in a group and the medium and average students in a separate group and the strong students in a separate group?
I'm always mixed up.
Okay.
When you say, if you just divide up the groups according to this strongness, maybe that might also work.
Okay. Yeah. Okay. It can. There are advantages and disadvantages to both. Depends. I think you were shaking your head though.
No, I would not separate them into, because
by ability.
That would get more grading.
Okay.
So it creates the morale.
Okay. So it depends. Sometimes students will realize, oh, she put me here because we're the dumb students, and they'll think, oh, we're being treated as dumb. So sometimes it can be kind of demotivating when they realize, oh, we're in the dumb student group. So there are advantages. Sometimes the weaker students you can put in a separate group, and then you can give them more attention during the group time. And then the strong students are pretty independent, and they can kind of go beyond what you normally would expect. They can kind of, you're giving them a physics problem, and the strong students are already building their spaceship while you're helping the weaker students figure out the basic physics of time travel or something.
The criterion is not necessarily stronger or weaker students in the performance, but more active in speaking.
Yeah. So introverts and extroverts, for example.
Yeah.
Okay. Okay. So mixed groups. Okay. So first, ability level. Mixed groups of different ability levels. There's an advantage to that because the stronger students can help the weaker students. They can explain things. You can put a strong and weak student together, and the strong student can give extra help to the weaker student. The stronger student even grows by the process of kind of teaching or tutoring his or her peer, and the weaker student gets the benefit of a peer teaching him or her rather than a professor. There's an advantage to that. Introversion, extroversion, or activity. Do you want a group of just introverts together? If they're really introverted, that may not work. They may just sit around and stare at each other.
Yeah, that's what I worried at first.
That can be.
After I heard your second suggestion, maybe in teenager students, if they got only among themselves, then maybe they are more outgoing.
Yeah, so it's possible. If you put, sometimes if you have, especially students who are too dominating, and then the introverts might just feel like, okay, I have nothing to say, he's always talking. That can be a problem. And you might actually have to have a group leader to control over dominating students, or you yourself might have to intervene and do something with a student who's too dominating. Or you might have to pull out the introverts and put them into their own group where they're more comfortable, and there maybe they'll be more expressive and talkative. But if you have a group of people who are too shy, if you have 5 kids who are just completely shy, then you might need to put some extroverts in there. So it really depends on the classroom dynamics and the situation, how mature they are, cultural variables. If you have foreign students, it can be good to mix foreign students in with the Koreans. Sometimes the foreign students might feel intimidated because the foreigners speak good English. Other times the foreign students can help the Koreans to talk because the foreign students will be more willing to try to talk to and engage the Korean students. So it depends really on the classroom dynamics and personalities and their age and maturity level. Gender too can sometimes be a factor and such. So this is kind of the difference between homogeneous and heterogeneous groupings. And homogeneous means they're all the same in terms of maybe ability level or introversion or age or gender or something like that, as opposed to heterogeneous. Yeah, so homo means same, hetero means different, and this is really the same thing. I think that's from Latin, that's from Greek, but it's the same meaning, it means type or kind. Just this has an extra E because this is from Greek. Greek and Latin were close cousin languages. And that's why the Heterogeneous has an E in it. Okay, so those are some considerations for group dynamics. And again, when you maybe join in to help a group for a few minutes, I mean, your presence, again, can depend on whether you're sitting right across from a student or if you're next to the student, if I do like that. Is this more comfortable?
Better.
Okay, it's better. So it's more comfortable. This is actually kind of the job interview dynamic. In job interviews, they place you right across from the main interviewers because they want to see how you act under pressure. Okay. That's why they do job interviews like that. Okay. Okay, so those are some considerations for group dynamics, and actually I have a whole booklet online on group activities. I think it's one or two, I don't remember. Can't remember. I've got so much stuff on the website I can't keep track of it anymore. I don't know what I've got on the website here. I should have something on group dynamics, do I? Types of group activities, introduction to group activities. Those are the original. I should combine those into one booklet. Maybe I should put the new link up there. It doesn't matter, same thing. One is kind of a more general thing to rationale for group activities, dynamics and such. The second one, types of group activities, is what we'll talk about in a few minutes. Different types of group activities that you can do in different classes. And I'm not really going to go into the question types. We've talked a bit about that before, and I've got stuff on the website about that. One more question though. Maybe talk to a partner for a minute. Why is it that students can learn better from group activities or interactive activities rather than listening to a lecture? Why is that? Talk to a partner for a moment. What's the advantage psychologically for learning from group activities, interactive activities, than from passively listening to a lecture? What are advantages, what are the learning advantages of group work, or how does it work in terms of learning?
If we put the student into groups, we give each student the opportunity to speak up, so we would increase the concentration of each student.
Okay, students get the chance to talk to each other and to talk themselves instead of listening to the same professor talk for 50 minutes. So there's an advantage for attention, because adults listening to a lecture, their attention goes down after about 10 minutes, and after that their attention is not as strong. You don't have as much mental resources to pay attention at the same level until maybe when you see that 5 minutes are left on the clock and we're going to get out of here soon. Okay. What are other advantages?
What I also observe is that in our learning, or even when we read, our understanding of the content varies.
Mm-hmm.
Sometimes we even understand it wrongly.
Mm-hmm.
And so through group activities, you might say something and your friend says, no, it's not like that. And as you brainstorm and you even seek further clarification, it tends that those things seem to stick longer
Okay.
after the classes.
Okay. So there's this sort of brainstorming effect that you're kind of mentioning. Psychologists call it the generation effect. That's a psychology term. If I just explain to you, if I just lecture to you, your understanding may just be superficial. But if I give you either an inductive activity or a group activity, an inductive activity where you have to figure out something by yourself, which can often be done as a group or pair activity. If you had to figure out something yourself, which is more memorable, that or passively learning from a lecture? Okay. When you figure out something by yourself, your brain is generating an understanding, a schema. We talked about schemas before, that conceptual framework. Your brain is making connections. Your brain is being challenged, and by figuring out something yourself, you get a deeper understanding. You form stronger mental connections between the new knowledge and what you know before. You're forming basically stronger schemas psychologically, stronger connections, stronger networks of knowledge in your brain cells. and you're more likely to remember that. So you are generating knowledge yourself rather than passively taking in knowledge. You're generating knowledge, generating understanding, generating that conceptual framework, which psychologists call a schema. So that's the generation effect, which is something we've known about for a long time in psychology. The generation effect means that students generate the understanding themselves. They will understand it more deeply, they will remember it better, and will actually practice an example later on. Any other reasons?
I did teach a course some time ago, and I thought I did my best, but unfortunately one of the students, after the course, said, we realized that you are very passionate about the things that you teach, but unfortunately, the way you talk about it and you see it so abstract.
Yes.
And I thought it was basic for them to know those things, because like you can just visualize them. So it gave me a different idea about what I need. I think I want to teach, and then what they also know. So through some of this, you can actually know the understanding level, the level of knowledge where they are,
yes.
So that you can build on that, rather than sometimes just giving it to them and use everything like in space and
yes.
you can connect them.
Yes.
Waste of my time.
Yeah, that is the expert paradox. It's basic to you. You may not realize to them it's not at all basic. To them it's very abstract, very difficult, very hard. And so you don't really realize how difficult it is for them. Or what it's like as a beginner to try to understand the stuff and how to explain it to beginners. My first semester as a grad student in linguistics was terrible because I had professors who had no idea how to relate to new grad students. And they always talked at a level way up there that we couldn't understand. And my first year of grad school was miserable because I suffered through very theoretical classes that were taught very theoretically. That's the expert paradox. You're an expert, you don't realize how to explain it to beginners. You understand it too much, that you don't know how to relate to beginners. And again, what's basic to you is like a different language to them. Okay, so there are also social motivation reasons. Doing something in groups socially, it's also socially stimulating. It's better for your confidence, it makes it more fun to learn in groups. And so there's also, it's a kind of a motivational effect for students too. They can feel more at ease, they can gain more confidence from speaking with each other perhaps, and just from the learning experience in a social context. The learning becomes more social, becomes more fun, and that makes it more motivating, more stimulating than a scary professor who's lecturing from kind of up in the clouds, and at an abstract conceptual level way up in the clouds and such. Okay, so some other considerations actually that are on page 2. We kind of talked about some of these before, or some of these already. We talked about learning benefits. Number 3, how do you get students to do group work? Well, like I said, start slowly through simple things like pair discussion, simple pair discussion questions. Earlier we kind of talked about evaluating group projects. So for one thing, participation, I make participation part of my grade. And we talked about this before last week in terms of assessment. In my assessment booklet online, my assessment booklet, there's actually a sample rubric on how to grade group participation or class participation. And we talked about before also grading group work. I talked about the example of group exams. This could be true for group presentations, other group projects. You could give everybody the same grade based on the quality of their work. You could also give individual grades or a combination, like half of their grade is a group, they get a group grade and they get an individual grade. Or let's say if I have group leaders and I trust my group leaders, I can say, okay, you're the group leader, tell me, maybe through a little survey, which of your students in your group did pretty well, would deserve extra points, or which ones were problems and should be deducted. So I can get input from the group leaders, or I could just give everybody in each group a little piece of paper that says something like, did everybody in the group participate equally? Was there somebody who dominated, did too much? Was there somebody who didn't do enough? What were their names? And kind of asking the students to spy on each other. In America that works. I don't know if that works in Korean culture, but maybe in Korean culture you might want to use the group leaders. Again, you want to make sure that the group leaders are not too dominating, not the hyung phenomena where the group leader says, I'm hyung, and will do what I say. You want to make sure that that's not happening. If so, you might have to talk to the leaders or assign new leaders if you're going to rely on group leaders for input and such. So those are some options. I usually just give everybody the same grade because I generally assume that the dynamics, from what I can tell, are fine. But if you have a smaller class, you can do things a little more complicated. Okay, now I wanted to also show you another example of how it works and why, and move into particular kinds of group activities. So here's an example of a physics professor at Harvard and what he does.
Professor Eric Mazur teaches physics at Harvard. Over the years, he discovered that students in his introductory physics course were passing exams without having understood the fundamental concepts he was trying to teach. In response to this problem, Professor Mazur developed a variety of interactive techniques linked to each other in ways that help his students learn basic concepts far better than before. Requiring students to read, think, and reflect before the lecture is the first step in Professor Mazur's interactive process. He also uses the course website to monitor their learning and communicate with his students.
I don't go into the classroom lecturing on what I think they need. No, they tell me what it is that they want me to cover.
Okay, so last time we talked about these kinds of pre-class activities, and that's what he's talking about. Before the class, they have to answer some questions about the reading that's going to be lectured on or discussed in the upcoming class. Pre-class assignments, we discussed that last time. So that's kind of what he's talking about here, where they have to answer some questions maybe online. They read the chapter, answer some questions about it. He gets that in his mailbox or through EKU or some online system. So he goes into class knowing what problems the students had, what their strengths are, what their misunderstandings are. And so he just starts from there. He doesn't lecture about the basic stuff. He starts from the misunderstandings, the strengths and weaknesses he's found through a pre-class assignment.
Helpful for Professor Mazur to answer those questions that we had. And sometimes it didn't feel embarrassing at all if he addressed your specific question because the whole thing was anonymous.
So the idea is to teach by questioning rather than telling. I will talk a few minutes and then put on the overhead projector a question. And then I tell them, take a minute to think about it. They think about it. And after they've thought about it, I need to get some feedback.
Okay. So there they're using clickers. Now this is more common in science classes. You don't have to use clickers. But a clicker is each student has, each student would have to buy a clicker device. Nowadays there are cell phone apps that do this, smartphone apps that do this, so they don't have to buy a device. But a few years ago, colleges were requiring them to buy these devices for their science classes. But basically, he gives a multiple choice question on the screen. They have a clicker where they click, they send in their answer. It goes to his computer, his laptop, through software. The teacher has to buy the software, or the school provides it. And so the answers come to his computer, and so he has a tally how many students answered correctly or incorrectly. So right there he gets some information about how well they understood.
On their answers.
So turn to your neighbor and see if you can convince one another of the correct choice.
So here's the point, they have to talk to each other. What's the correct answer? Why?
And B is down, so the force at the bottom will be upwards. And in a sense, this process, this engagement, this teaching by questioning rather than by telling, forces students to develop these models in the classroom.
I think the lectures are really good, and it worked out really well, the idea of everyone teaching each other.
And we soon realized that, yes, we were picking up the material faster than we had in the previous physics course that we had all taken,
You can forget facts, but you cannot forget understanding. And that's actually exactly what I would like to achieve here. I want them to understand the subject so that they know it for the rest of their life.
Okay. I like what he said, you can forget facts, but you cannot forget understanding. I like that. And so there are different flavors of group activities, and sometimes they overlap. What you saw there was a sort of team or peer teaching, which is a kind of discussion activity where he gives a multiple choice. He gives a question, multiple choices. The students have to answer, but then they have to turn to each other in groups and discuss what's the correct answer, why. And maybe in your group, you say A, you say B, you say C, and you have to convince each other why is this the correct answer. And in the process, you work it out, and you get the generation effect really going. You figure it out by yourselves, you explain it to each other, or the person who understands it explains it to the others. And that can be more effective, as he said, if a student has just come to understand it, they can explain it better on the level of another student who doesn't quite understand it, because she has just understood it and she knows how to explain it to her classmates better than an expert. This isn't just basically a variation on the sort of inductive group exercise where they think inductively. There are many other variations on these kinds of group activities. If you're teaching, say, grammar, instead of just lecturing about the perfect tense, like I have gone, give them a text or a conversation sample with examples of the perfect tense and other verb forms, and have them figure out what's the function of the perfect tense here. Or you can give them, if you're teaching something more complicated like articles, like A and the, you give them a text with corrections where the articles have been corrected by a native speaker, and say, okay, what was wrong here? Why should this noun have the? Why should this noun have no article? So you can give them like some data, some examples, and have them inductively figure out what's the principle. How is this verb form being used in this context, or why was this wrong? Or you can give them two versions of a text, one that's correct and one that's incorrect, and say, okay, what were the mistakes with this verb form here? Why is this correct? Why is this not correct? Those are types of inductive exercises. And so inductive learning is often a part of group activities. And so here under types of group activities, there are various kind of variations. Think, pair, share is kind of a term for what I've talked about, pair discussion. Sometimes in education they use the term think, pair, share. You think for a minute, you share your ideas in pairs with a partner, then you share it with the whole class. Or the teacher calls on some pairs and asks them for their opinions and so on. Then you build up to maybe more, group discussions. It could be all kinds of open-ended questions, or it can be something closed-ended. I've kind of come to some of these. Problem-based learning is number 6 here, and it's kind of similar to task-based learning. So some kinds of questions you give them, there might be a correct answer, like this example, or it could be more open-ended discussion. It really depends on the field that you're teaching and the type of content that you're teaching. But one kind where there's maybe a correct answer, that case that was kind of peer teaching, peer instruction. There's another kind where you give them a case study, and there is probably, so it could be a case study like in business, could be in medicine about a patient. Maybe in business you have to come up with an analysis of a case study, why this business succeeded, why this business failed. That's a bit more open-ended, where there might not be one correct answer, or maybe there is according to one model, or you could critique it, what 2 different models or theories would say about why this business failed. In medicine, for example, that's an example where there's one correct answer, and this is where we often use problem-based learning. This developed in North American and Canadian medical schools and nursing schools when they realized that students weren't really learning very deeply the traditional way through lecture, so they developed this. So let's say in medicine, of course, you have to get the right diagnosis. There's one right answer. And so what you do is you give students a case study about a particular patient, his or her medical data. 65-year-old man complains of these symptoms. You give various data about the patient and his symptoms, her symptoms. What's the correct diagnosis? And there has to be one correct diagnosis. And they will discuss this in groups and try to come up with the correct diagnosis. Now, how could you make this kind of problem simpler or harder?
Asking more questions, like differential analysis, and asking what diagnostic test you should do.
Okay.
For the treatment.
Okay, so they have to come up with like what diagnostic tests should be run here. That's one thing you can do. What else can you do to make it either simpler or harder?
I think making it harder would be, an example would be like giving an incomplete case, like missing data.
Okay.
And then you could ask which kind of data would you use in order to diagnose this.
Okay. You can give them a case with some missing data and they have to figure out what more information do we need, what tests do we need to run. Or you can give data that's not exactly relevant and they have to figure out what data are relevant, what data are not relevant to the analysis. This could be true for medicine or other fields. So they have to figure out what data are important here, what data are not so important. Or along the lines of missing data, it could be information where they don't know that much. Let's say the list of symptoms and mentions I don't know, tachycardia, which is rapid heartbeat. Maybe they don't know yet much about tachycardia, about rapid heartbeat. So they have to actually go and do some more, they have to find information on their own. They have to do sort of research. Go to medical books, go online. They actually have to hunt down more information and find out more information. And this is a common method in problem solving and team-based or task-based learning. They have to go out and find more information. And maybe they have to, and especially if it's a big group like 6 students or 8 students, then they will kind of divide up the labor. This person will find out more information about this aspect. Student B will find out more information about that aspect, and such. So they have to find more information and then discuss the information that's relevant. If you want to make this even more complicated, this is something that's kind of done in advanced language classes. It's called Jigsaw. You see Jigsaw on there. So some of my Korean friends were teaching Korean to kind of Korean Americans in America, what we call heritage learners. They've grown up with Korean-speaking parents, but they're Korean. They don't really know formal Korean that well or written Korean that well. And they need to, so they're taking Korean classes in order to really improve their Korean. They have kind of a passive knowledge of Korean from the home, but they lack knowledge of formal and written Korean and some advanced Korean. So in this case, they designed a kind of scenario that involves maybe multiple meetings, either in class or outside of class, where they're in teams and they pretend they're job hunting. They're going to Korea and they're going to look for a job and look for an apartment to live. And so they have to actually maybe go online and do, maybe some people look on information on certain kinds of jobs, or other people look for information on other kinds of companies. They break it up. So let's say we have groups like 1, 2, 3, 4, and within each group you have division of labor. Like one person is looking at aspect A, which is certain kinds of companies. B is looking at other kinds of companies. C is looking at other kinds of companies. D, and so on. Or it could be apartment hunting, where they have to look at different types of housing. Like A is looking at villa apartments. B is looking at contacting realtors. C is looking at different areas of Seoul to live and such. So you have like maybe 4 teams, and you have person A on each team is looking at this aspect, and B is looking at this aspect. And so they're all working together as a team, but at some point, maybe the A's from team 1, 2, 3, and 4 meet together and say A's have been looking for information on villa apartments. And so the A's from teams 1, 2, 3, 4 get together and share their information on villa apartments. And the B's get together and share their information about different regions of Seoul, which are better and such. And then they go back to their original groups and share their information that they've learned from the people on the other teams. That's a kind of jigsaw. And this could also be done in connection with problem-based learning and team-based learning. That's kind of a very fancy kind of team activity. Other kinds of team activities, a lot of these overlap. Discovery learning, challenge-based learning. That's when I give you some information, some data, and you have to kind of inductively figure out the principle. So for example, in statistics, if I'm teaching statistics, which I wouldn't, but if I were, well, actually I had to teach kind of basic research methods once for language research. And so I had to teach some basic statistics concepts. One thing that's a little hard is the idea of variance and standard deviation. So you kind of know averages, but standard variation or deviance is something a little harder to teach or understand. So let's say I give information on the performance of certain machines. Let's make it something interesting. Let's say if the students like to play golf or tennis, these machines, you go to the practice tennis places or practice golf places, these machines that shoot the balls at you. Maybe you have information about different machines by different companies and how accurate they are. So it's not just the average, but the accuracy in terms of each time how much does this ball vary from the average or the target. So that's kind of more like variance. So you give them data like that. It could be machine performance, or it could be some other kind of data set. And they have to infer, you give them, how would you, the problem is that you give them, find some way of measuring the reliability of the machine. So it's not just the average accuracy, but the reliability. How often is it more likely to deviate from the average or be closer to the average or the target? And that's the statistical idea of variance or standard deviation. And that's an inductive activity, kind of discovery-based learning. Now let me give you a variation on that. And this is, by the way, a Stanford math professor came up with that idea of how to teach variance and deviation that could be applied to other things. Let me give you something else. This is called an invention activity. I'll explain how it works. Okay, so I'm going to give you a task. You're going to design 2 zoo display cages. So you have these cute little squirrels, and you see their size and their weight, and you have these cute little mice. And you want to design 2 different displays. Each display, each cage has squirrels and mice. But exhibit 1. So you're going to design exhibit 1 so that, okay, so there's a partition, and you want to design it so that the mice are able to go back and forth, but the squirrels are kept confined to one side. That's exhibit 1. And then you are going to design exhibit 2, where the squirrels are allowed to go back and forth, but the mice are confined to one side. You cannot hurt the animals, you cannot use cats, you cannot confine them, you cannot chain them or tie them down. They have to be able to move around freely, but they're constrained by the design of the box or the cage. So let's have maybe a group here, and I guess you can join that group, and then you have 4 and then 4. So discuss how would you design your zoo exhibits according to these criteria. What I could do is I could do a fun variation on this. When I saw this demonstrated once at a conference. Let's say if we have a bigger class and we have like 6 groups, I might say have okay, group 1 and group 2 explain your ideas to each other, critique each other's ideas, and maybe you'll try to point out weaknesses in their ideas, or say, okay, which came up with the better ideas, and that creates even more analytical discussion and more fun. We don't have time today to do that, but I saw that done once and it was really fun. What ideas did you have for exhibit 1? Okay, this group. Your ideas for exhibit 1? Keep the squirrels from passing?
That one was really easy by just making the gap between the 2 chambers just about the size.
Oh, like a chasm?
Separate and then create a channel.
Oh.
The size just about that.
Okay, so it's kind of like jumping over a cliff, and if the mice jump, they go, well, splat, and they die. No.
Like we create a space like that type of thing.
A what?
Between there are two different chambers. So between the two chambers, we can just create a space.
A space, a big space.
That can take
Okay.
the size of only the mind.
Oh, okay, so a hole. It's very small. Yeah, so a hole that's very small that only the mice. That's okay. So that's a common solution, pretty easy one. Okay, a lot of people will come up with a tunnel or hole idea. What else? Any others? Either group for Exhibit 1. Did you come up with something different? No? Okay. Some people might have kind of like a scale, and if it's too heavy, the scale won't let the door open, but if it's light enough, maybe the mice can get on the scale and the door opens. Of course, the problem is you still have to have a passage that's small enough that only because it's like if you have a secure apartment, so a resident knows, if you want to sneak in, you're a bad person wants to sneak in, all you have to do is wait for a resident to come and punch in the right key code and open the door, and you can sneak in behind, and squirrels and mice could do the same thing. But yeah, usually people will think of something like that. How about Exhibit 2, where you keep the mice confined to one side, but the squirrels can pass?
Yeah, we actually use the scale idea.
Okay, the scale idea. So the scale only responds to something that's as heavy as a squirrel, and then it opens the door, and then you have to make sure that the mice don't sneak in behind the squirrel. That could be a problem. That's a common idea. Okay, what else?
Realize that the climbing pattern of mice, they prefer to have they climb with very short spaces. So if you could create something like a hedge type of thing, and then make the spaces a bit bigger.
Okay, sort of like a ladder where the steps are too far. Okay.
The squirrels will find it much comfortable to jump over that.
Okay, so something the squirrels, like a ladder the squirrels can climb, but it's too big for the mice. That's clever. Okay, what else? Did you come up with some ideas here? People will often think of maybe a partition that's very slippery and it's high enough, but the squirrels can maybe climb or jump over it, but the mice cannot. It's too tall and too slippery. Or maybe you can kind of curve it over like this, where the mice cannot climb without falling down, but the squirrels can jump over it. And those are typical ideas. So this in itself can be a fun activity, especially like for a language lesson. But let me show you what this was designed for originally. This came from actually biology, where this whole thing is an analogy, where they do it first as an analogy before actually teaching the biology concept. Anybody in biology? Biologist here? Okay, do you have any idea what this is like in biology? Pardon? Yes, cell membrane permeability. Oh, you've had some biology. Yes, cell membrane permeability. Okay, so if you have a cell, any kind of cell in the human body or any body, the cell has to allow certain chemicals in, like water, nutrients, phosphorus, and such, but it has to keep out chemicals that are undesirable, like toxic chemicals. And cells have very complicated and sophisticated ways of doing this, different ways of doing this, either by, according to like the passageway or the shape, that keep out allow in or keep out molecules of a certain shape or size and such. So there's sophisticated ways of doing this. What biology professors in Vancouver found is they would lecture on this concept, but after the course, after the semester, the next semester, the students had forgotten the lecture, the concepts of cell membrane permeability, and their lectures of the different mechanisms involved. So they found this. They did this as an activity, and the students are going, we're supposed to be learning about cell biology where we're doing this. But they do this, then you connect it with the lecture about the different mechanisms of cell membrane permeability. And then they found the students actually understood it better when you connect it with this analogy. They've done this activity, and then they've learned the cell principles. They actually remembered it better. They learned it better, and they didn't forget the next semester. So this really worked. This is a kind of an analogy activity. And this is kind of like probably the most, really complicated. So an analogy activity like this, or an invention activity, that's an analogy, jigsaws, that are perhaps the most complicated kinds of things. Yours don't have to be so complicated. Didn't get around to any humanities examples, but if you're in history or philosophy and such, of course, you can think of all kinds of case studies, analogy examples in philosophy. Michael Sandel does excellent lectures on ethical philosophy, where he comes with actual interesting examples or real-life examples and has students debate those in order to discuss ethical philosophy, and those are really good ideas. Something else on here I didn't talk about because I've never done it myself, service learning. I've never tried service learning, but that's when you have students go out your students go out into the community and they do something for the community. It could be teaching. You're teaching them, and then they go out and teach it to underprivileged kids or poor people or orphans. Or if it's engineering, they go out and they design something that will benefit the community. They design some kind of project from their engineering skills that will benefit the community and such, or they do something for the community. So it's kind of community service learning, volunteer activities, and there are probably many options for that. Someday I would love to do that, but I haven't been able to. So this is just an overview of group activities. You can go to my booklet online on types of group activities. There are more examples in there of different kinds of group activities, including, and I also have a separate handout on grammar teaching and activities for grammar teaching if you're a language teaching person and such. Boy, this is hard to cover all this in one lesson because it's so fun and so much stuff, so many different kinds that you can read about. If you have any questions, you can ask me afterwards. Otherwise, I hope to see you maybe next week when we talk about conference presentations. Thanks.